Hi AB Calculus students. This is 2017 number 6. It's a table question. I'm calling it a table question because they give you a table. I really think the AP exam only has so many questions they can ask, and something like this is definitely a candidate. Like, I really believe like a lot of the stuff from this, maybe one or two of the parts, will be on the test. So really pay attention, make sure you see what's going on here, and enjoy-ish. All right. You can see they give you a couple things. They give you the graph, they give you a table for g and g prime x. Here they give you the graph of h, and here they give you the equation of f. All right? And a lot of stuff going on here. All right. So let's go ahead and do the first thing. The first thing says find the slope of the tangent line of the graph of f. Well, what equation gives us the slope of the tangent line? F prime. So they could have made the question a lot easier by just saying, hey, find f prime pi. But remember, they always want to see, do you actually know what you're doing? So by saying slope of the tangent line, they're making sure people know, hey, if you want to get any points here, you better know the slope comes from the derivative. It's an easy idea, and you guys know it, but I wanted just to point that out. So before we can find the slope of the tangent line at x equals pi, and our slope comes from the derivative, we're going to have to find the derivative. So here we have f of x equals cosine of 2x plus e to the sine x. And when I've given you those quick, easy derivative and integral worksheets, it's because a lot of times the derivatives you have to do by hand on the AP exam. They're not difficult as long as you know the formula. So let's go find the derivative here. So here the first thing we need to know is what's the derivative of cosine u. The derivative of cosine u is negative sine u times chain. And the chain is a 2. Instead of putting the 2 here, I'm going to put the 2 here. So the derivative of cosine u is negative sine u times chain. That's it. And over here we need the derivative of e to the u. And the derivative of e to the u is e to the u times chain. The chain would mean what's the derivative of sine x, and that is cosine x. All right. And now we simply need to plug in a pi. So I put a pi here, and that's going to make this a 2 pi. I put a pi here. And I put a pi here. Now, while I have told you you do not have to simplify things, there is something you must simplify. You cannot leave sines and cosines. If you have a sine or cosine, it will have a pi or pi over 3 or pi over 4 or pi over 6 or pi over 2. It'll have one of the quadrant angles or one of the triangles. You have to finish with the pi's. Okay? So quickly, let's just look at where these two items are. Here is where pi is. So we have 0, we have pi, and we get all the way back around, and here's where 2 pi is. So in this question, we're looking at pi and 2 pi. So at pi, we have the ordered pair negative 1, 0. And remember, it's cosine and then sine for the x and the y. And over here, we have 1, 0, and again, this is cosine and sine. So when we get to the part of the problem where I need sine of 2 pi, sine of 2 pi is a 0, sine of pi is a 0, and cosine of pi is a negative 1. So my answer is negative 2, that's a 0, sine of, that's a 0, and oops, cosine of pi is a negative 1. Okay. And you can be done here. If you wanted to simplify, obviously that's 0. E to the 0 is 1. 1 times negative 1 is negative 1. You just get negative 1. But at this point, when you've gotten rid of the sines and cosines, you live in a beautiful country. This is how I choose to write negative 1. Nobody can stop me. And all that was part... Hey! Oh, proper motion there. Wow, that was more than 6 feet. If you're more than 6 feet away, that's good. You should be about 20 feet away after that. All right, let me erase part A. And now let's talk about part B. Okay, so part B says let k of x equal h of f of x. and they want us to find k prime 5. Well, k prime pi. Before we can find k prime pi, we need to find k prime x. And this is the old FU question. If you have FU and you want the derivative of FU is f prime u times chain, the derivative of u. So it's the big old FU derivative here. So the derivative of HU is H prime U times chain. And the chain, the derivative of f prime x, the derivative of x is f prime x. Okay. And now we need to plug in a pi. Okay, couple things. First thing, this right here we did in part A. Remember how we had -2 times 0 plus e to the 0 times -1? That's right here. Now you can write that unsimplified version, or if you remember, we also said it could just simplify to -1. So now we need to find what is f of pi. So I'm going to look way over here to see if I can figure out what f of pi is. So if I look way over here, f of pi is cosine of 2 pi plus e to the sine pi. Cosine of 2 pi, on that ordered pair, the ordered pair we had over here, remember this was 1, 0, so the cosine is 1. And sine of pi, we already said was 0. Over here, the sine is 0. All right, so this is 1. This is e to the sine pi is 0. So we get 1 plus 1, which is 2. Let me make sure that's right. Yes, it's correct. Okay, so we're almost done with this question. So how are we going to finish this question? Let me erase this to make space. So now I need to know what is h prime 2. We already have this -1 here. So what does h prime 2 mean? Well, let's look at what they gave us. They gave us the graph of h. If they had asked for what is h of 2 would have been the ordered pair at 2. But we don't want the ordered pair at 2. H prime 2 means we want the slope. What is the slope at 2? So you will notice this graph goes down 1 and over 3. So the slope of the tangent line here, down 1 over 3, is simply -1/3. And if you multiply those together, you get +1/3, but you don't even have to do that. So again, you had to recognize h prime 2 meant what's the slope of the tangent line at 2. Since this is the graph of h, the slope of the tangent line there we can find. It's just the slope of the line, down 1 over 3. And that's part B. So let's go to part C. Alright, so for part C, they want you to take, and again, this is what I'm talking about, like this right here. This is what the AP exam is going to want to do this year. You can't look this stuff up online. So that's why they're going to do this. Here they want to know what is m prime 2, but before we can find m prime 2, we need to find m prime x, and to find m prime x, we're going to have to take the derivative. We've got to use the product rule. Okay, so the product rule. We got the first piece times the derivative of the second piece. The derivative of h of x is h prime x plus the second piece, h of x, times the derivative of the first piece, the derivative of g to the u. And if we look over here, derivative of fu is f prime u times chain. Same idea. So the derivative of gu is g prime u times chain. Okay. And now we're going to plug in our 2. So if I plug a 2 in there, it's going to give me a -4. 2, a 2, a negative 4 when I put it there, and then times a negative 2. All right, let's go one piece at a time. First thing, what is g of negative 4? G of negative 4 is directly from the chart. It's a negative 1. Now let's look at h prime 2. H prime 2 is the slope of the tangent line at 2. We already discussed that slope is negative 1/3. H of 2 is going to take some work. H of 2 simply means what's this ordered pair here? Now, you might think, well, Mr. Pyga, this is crazy. It's some crazy decimal. Well, think of this. If this graph goes down 1 and over 3, so if it ends up going down 1 and it takes 3 to do it, here it's going to be down at 1/3, and then it's down at 2/3, and then it's down at 3/3. You see each time it goes down a third, a third, a third, so that the time it gets here it's down by 1. So at 1 it would have been at negative 1/3, at 2 it's at negative 2/3, and then at 3 it's at negative 3/3, which is of course negative 1. So this is down negative 2/3. So h of 2 is the actual ordered pair, which is that. All right, next piece, g prime negative 4. Oh gosh, I messed up the first one. Alert, alert, alert. That was g of negative 4, which was 5. And now this time I want g prime negative 4. Some of you were watching. Fix it, Pyga, fix it. You're going to find your mistake. Okay, and now this is where I get to use the negative 1. Okay, so I'm going to look at the answer here. 2, negative 2, negative 1, and negative 2/3. Looks good. 5 and negative 1/3. Looks good. Online, they simplify all this and they get negative 3. Do not simplify stuff like this. Leave it, get your points, run away. Good job. All right, that's done. We're going to go to part D. All right. Part D says, is there a number C on the closed interval negative 5 to negative 3 such as g prime C equals negative 4? Okay. Now, we're going to use this table, and there's actually two things we can check. First of all, I want you to notice that they said specifically in the question, if you read the question, they say that the table gives values of g and its derivative g prime at all selected values. Okay? So, oh, and g is a differentiable function. Okay, so it's important that g is differentiable. So, let's see. Can I prove that g prime c equals negative 4 using the IVT? All right. The IVT says, let's look at the graph. By the way, it's not going to work. But let's look at the graph of g prime x. So I'm going to make a graph of g prime x, okay? And it goes from negative 5, negative 4, negative 3, negative 2, negative 1. Again, this is g prime x. It's down here at negative 3. It goes up as high as 4. I just want you to see this, okay? So the graph of, and again, I'm labeling this one g prime x. My ordered pairs are negative 5, negative 3. And then it goes to negative 1. And then it goes all the way up to 4. And then down to 1. And then the negative 2. And then the negative 3. Okay. Now, and that one was a little bit low. My eyes are a little crooked. Now the question is, are we ever guaranteed that the graph of g prime will ever hit negative 4? Well, you look at this. If we were using the IVT, to get from here to here, it would promise me I'd have to cross numbers between these two. So it would have to cross negative 2. To get from here to here, the IVT would promise me I'd have to pass any numbers between these, anything between negative 1 and 4. To get from here to here, it would promise I'd have to cross through any of these numbers. So basically, the IVT could be used to prove that g prime, because I have to look at the graph of g prime. IVT, if you want to prove something about g prime, you got to look at the graph of g prime and look at the ordered pairs. it's guaranteed to go between anything between, look at the lowest number, -3, and the highest number 4. The IVT would prove that we could use it if we were trying to cross any number between -3 and 4, but not -4. We're never guaranteed it's going to work. Okay? So IVT won't work. Remember the IVT, if you want to prove something about G prime, you got to look at the graph of G prime and look at the ordered pairs. Are we guaranteed to get from here to here, crossing the ones in between? So now we have to look at the MVT. Now remember what the MVT is. The MVT says F prime C, of course it's G prime C here, would have to equal F of B minus F of A over B minus A for some, but the function's got to be differentiable. And again, this is the MVT. The picture of this is the slope through 2 points. So if I found the slope, now I don't know what my graph looks like, so maybe my graph looks like this, but the MVT guarantees that if I find the slope through my endpoints, then I can prove something must happen about the derivative if the function is continuous and differentiable. There must be some C between A and B such that the slope of the tangent line, where this is the slope of the tangent line, is equal to the slope through the endpoints. Those would have to be the same slopes. So the mean value theorem, you can use ordered pairs to prove something about its derivative. But you can only use it if it's differentiable. So here I would say, because G is differentiable, the MVT applies. Okay, they told me it's differentiable. Now, on this problem, they are wanting me to use the interval of -5 to -3. So again, the formula I'm wanting to use is G prime C has to equal G of B minus G of A over B minus A. So let's look at the ordered pairs here. What is G of -5? So I have -5 comma what? If you look over here, G has -5 comma 10. That's a 10. And then look at the other endpoint, -3. G of -3 is 2. Or in other words, -3 comma 2. So the mean value theorem says let's find the slope through these endpoints. So we're going to subtract the y's on top. So let's just go this way. We'll do 10 minus 2. And then the x is on the bottom. -5 minus -3. And you'll see here you get 8 over -2. And 8 divided by -2 is -4. So by the MVT, we're guaranteed it works. And there you go. Alright, thank you for watching the video. Bye.